Comparative neurotoxicity of RDX and CL-20 in the earthworm. Earthworms are a critical creature for the Earth's ecosystem. Their activities of feeding and burrowing in the soil allows for organic residues to be incorporated, as well as enhancing the decomposition, nutrient cycle, and structural development of the soil. Earthworms help increase the amount of air and water that get into the soil by burrowing deep down in the earth and creating tunnels that allow for water to be transported through them. In this first column on the left, the second figure down, is the molecular structure of CL-20. CL-20 is an incredibly stable, energetic material that fascinates many researchers due to its structure that allows for energy to be trapped within the molecule itself. But it still has a high oxygen balance that allows for it to have a high detonation velocity. While it's a new compound, it's becoming the military's new go-to explosive. It is very sensitive to impact and friction, and to stabilize this, researchers are changing the environment it is in via co-crystallization. Co-crystallization is when two materials are crystallized from the same liquid. The co-crystal of Cl20 and HMX have been created, which has greatly improved the stability of Cl20. The figure below the molecular structure of Cl20 is an example of the explosive Cl20 itself in the field. In the middle column, the first figure at the top is the molecular structure of RDX. RDX is a nitroamide, just like HMX that Cl20 has been co-crystallized with. This means it is an energetic explosive that is more excited than TNT is. Typically, it is combined with other explosives and is commonly found in the explosive agent C4. It remains stable while in storage and is highly energetic and is popular in the world of military high explosives. Ingestion of RDX is rare, but it is possible if you are exposed to it during the manufacturing process or during wartime. RDX ingestion is most likely to happen orally and produces symptoms of confusion, nausea, vomiting, muscle spasms, and premature heartbeats. RDX is slow to absorb in the gastrointestinal tract, and whole bowel irrigation will be done to ease the pain. Earthworms were exposed to concentrations ranging from 0.2 to 2.15 micrograms per centimeter cubed. The chart on the top left in the third box represents the medial and lateral giant fiber conduction velocity following 6 days of exposure to Cl20, as well as displaying recovery days 1 and 7 to assess the reversibility of the neurotoxicity that has been reported with other chemicals. The chart in the bottom right of the third box represents the medial and lateral giant fiber conduction velocity of RDX, following the same exposure and recovery lengths of Cl20. Both Cl20 and RDX in increasing dosages had a negative correlation with both the medial giant fiber and lateral giant fiber. While there were physiological signs impacting the worms after exposure, as seen in the first column, the first figure, such as shrinking of the body and stiffness, these effects were mostly eliminated after a few days back in an uncontaminated environment. This proves that the neurotoxicity is reversible.